Hey guys, welcome back. So today what we're going to be looking at is determining linear equations. So this is actually the same learning goal as what we've done previously, but we've got a different success criteria for today's lesson. Because today what we're going to be doing is we're actually determining the equation of a line from given coordinates, whereas previously what we've done is we've sketched lines. So what we're going to do that, we need to have 2 points. Okay, so we are given 2 points on this graph here. So we can see that this is going through the y-axis. So this is going to be at 0, 6. And then we can see this point here is going through our x-axis, and that's at 3, 0. So we have our x and our y-intercept given to us for this one. All right, so remember, the goal for this is that we're trying to get it into this slope intercept form. So really what we're trying to do is we're trying to work out what m is, and we're trying to work out what c is. Now, because this graph actually shows us that c is actually equal to 6, we don't need to think about that one any further. The only thing that we need to work out is we need to work out what our gradient is going to be. And we're going to do that using this equation. So m is equal to y2 take y1 divided by x2 take x1. So this is just a fancy way of saying our rise over our run. So the first thing I'm actually going to do is I'm going to label my points. So I'm going to call x1, y1, and that's going to be 0 and 6. And then I've got x2, y2, which is going to be 3 and 0. I think it is so important to label these because I know for myself when I was in high school, I used to stuff this up all the time. All right, so let's go in and let's substitute these values into our equation to work out our gradient. So we know that our y2 was equal to 0. So 0 take away 6 divided by, and for this one, x2, 3 take away 0. Okay, so this is effectively going to be negative 6 divided by 3, which is going to be negative 2. So that's easy enough. Now we can substitute that into our equation so that we have y is equal to negative 2x plus 6. Let's just double check this. Let's go through this. So let's do this the old-fashioned way. So the rise, so we can see that we're going down. So we're going down 6 and then we're going across 3. So if we divide 6 by 3, we're going to get negative 2 again. So yes, that did work. Good thing I double checked. All right, so I want you to have a go at that now. So this is chapter 3.3 in your textbooks on page 84. So go through, have a look at the graphs, find the y-intercept first, nice and easy for these graphs, and then find the gradient. So again, you can do that using the big grown-up way that we've done. So the y2 take y1 over x2 take x1, making sure that we label our points. Or you could do it the old-fashioned way and do it using just the rise and the run. Okay, so here's the deal though. Most of the time, you're not going to be given a graph. You're going to be just given 2 random points, right? So we've got 2 points here. So negative 1 and 3, and then we've got 5 and 15. So this is where it gets a little tricky. So we can still find our gradient. So let's go through, let's find our gradient first. So again, I'm just going to make sure that I label because I always almost stuff it up. So we have x1 and y1 is going to be equal to negative 1 and 3, and then we're going to have x2 and y2 is equal to 5 and 15. So let's substitute those values into my equation now. So m is going to be equal to 15 take 3 divided by 5 take away negative. So when we take away a negative, it becomes plus 1. All right, so that's going to become 12 over 6 or a gradient equal to 2. So now we have our gradient. So what we're going to do, we can't just substitute this into y equals mx plus c because we don't know what c is. So we can substitute in the 2, right? So we can substitute in y is equal to 2x plus c. But now where do we go from here? We're going to be a little bit sneaky. We're going to use a trick and we're going to actually use one of the coordinate points. So I'm going to use my x1 and my y1. Doesn't actually matter which one you pick, so just pick one of them. If you like, not dealing with negative numbers, then I would probably pick the other one. I just like dealing with small numbers because I'm a lazy person. All right, let's substitute those values in. So 3 is equal to 2 lots of negative 1 plus c. So this is going to be negative 2. So if I add that to the other side, I'm going to get 5 is equal to c. Done. So now I can substitute this back into this part here so that I have y is equal to 2x plus 5. So what we can do now is we can actually double check using the other point. So I'm going to double check using x is equal to 5, and I should have y is equal to 15. So this should be equal to each other. So 2 lots of 5 plus 5. 2 lots of 5 is 10. 10 plus 5 is 15. 15 is equal to 15. Left-hand side equals the right-hand side. Therefore, we know the equation of the line is definitely going to be y is equal to 2x plus 5. It's a little bit trickier, but not really too much trickier. I think the hardest part is honestly making sure that we've labeled our points for our gradient. And once you've done that, it's really pretty straightforward. So what I want you to do now, I want you to go through these couple of questions here. So we're just going to do the first column, so just 3, A, C, and E. So this is chapter 3.3 in your textbooks on the same page as before. All right, so what happens when we are only given one coordinate? Okay, so previously we've had 2 points, or we've been able to see where the y-intercept goes. We're not given a y-intercept here, we're just given a coordinate and we're given the gradient. We're going to have to use a slightly different method. We're going to have to be slightly smarter about it. So we've got our equation here that we're using before to find our gradient. So m is equal to our change in y over our change in x. So we've just manipulated this equation a little bit. We've multiplied both sides by the denominator, and this gives us this new equation. So m times by the change in x will be equal to the change in y. So this is a special name. This is called the point slope formula. Okay, because what are we given? We're given a point and we're given a slope. So that's why it's called the point slope formula. All right, let's go through and let's have a go. So you're given the slope or the gradient, -2, and you're given a coordinate 10, 12. So we want you to go through and determine the equation of the line. So let's write down our point slope formula. So I'm going to actually write this with my y's on the left-hand side because I'm a little bit pedantic about it. And also notice that I dropped the 2, okay? So that's going to be equal to mx take x1. And the reason that I've dropped the 2 is just because it makes it a little bit easier for us to remember where to substitute these points into. Okay, so we know our gradient is equal to -2, so we can substitute that in. Now, this is going to become our point 1. So this is going to be my x1, and then this is going to be my y1. So that's why I've dropped that 2, so we know to substitute those points into only these bits here. So let's go. Y minus 12 will be equal to -2 lots of x take away 10. So now all I'm going to do is I'm just going to expand and rearrange. So I'm going to take that 12 over to the other side, and I'm also going to expand the brackets at the same time. So -2x, -2 times by -10 is going to make +20, and then we're adding 12 to that as well. So we get y is equal to -2x plus 32. So it's actually really simple. All right, let's just go in, let's double check. So I'm going to substitute in my value for x. So I substitute in 10 and I should get 12 as my answer. So 12 should be equal to -2 lots of 10 plus 32. Now I know that -20 plus 32 is going to be 12. So 12 is equal to 12. Left hand side equals the right hand side. Therefore, the equation of my line is going to be y equals -2x plus 32. All right, so that's it. I want you guys to have a go now. So that's probably the newest thing that we've done in this lesson is that point slope formula. So maybe go back through, practice a few more of these. I'm going to get you to practice the first column, so A, C, E, G, and I, and double check that with the answers in the back of the textbook to make sure that you know what you're doing. That is the trickiest part of today. So if you're having difficulties, please email me. Please make sure that you are keeping in touch with that weekly check-in. All right, guys, talk soon. Bye.